Good afternoon, everybody, and welcome to an epic series. So, the first of its kind, at least from our side, where we are going to look at some integration between robot and IDEA StatiCa. So, robot is robot, or rather, Autodesk Robot Structural Analysis Professional, also known as RSAP or RSA. And we'll be looking at three parts. So, part one will just be looking at how to progress or proceed from out of the robot space into the IDEA Statica space. And part two will deal with modeling and adding details to one of the complex connections. And part three will look at one of the other complex connections as well. So these will probably be slightly longer than usual, but really I hope that you gain a lot of value from them. And yeah, if you have any questions, based on anything that you see, you are welcome to email me at jacobus@mgfx.co.za. You can actually see it there on the page, or you can even pop something in the chat and we'll make sure that we get to answering that particular question. So, all right, without further ado, let's go straight into the robot space. All right, so within robot, we've got a very cool looking model. We do have some information on how to actually create this type of model. I actually need to refresh my memory as to whether or not we looked at creating the hopper. So the bottom hopper, sorry for that jump there. So this hopper here at the bottom, and also how to create your dome for your silo in such a way that it will actually form part of the wind simulation. So I think there should be something on that. If not, if there's something that you're interested in, please pop it in the chat. Otherwise, just have a look at our Micrographics page and our blogs page. There might very well be something on this over there. Okay, but we've got our model here. We've got a whole set of load cases. You can see we've got dead loads, live loads, and then we've got our wind forces. And we also used automatic load combination generation to create the load combinations you can actually see over there. So if we go to DL2, you can actually see there are some point loads there to simulate the mass of whatever these silos will be holding, or whatever material they'll be storing inside of these silos. And then you've got the live load, just maybe to simulate somebody climbing onto the structure, whatever it might be, so the loads aren't necessarily going to be what you expect. And then we've got all of our load combinations. Of course, that looks absolutely wonky, right? But those are the outputs. Oh, well, that's actually the wind load there. If we go to the load combination, let's see there. Okay, there's nothing in here because we're not displaying any of the outputs, but we are going to go to analysis and just run the calculation again, just to be sure that it's all good and well. And you can see there it's an errorless model, which is lovely, especially within the robot space. Sometimes you can get some strange errors in here, and they can be quite difficult to resolve. But so this is an errorless model, thank goodness for that. And we're just running the analysis again to make sure that everything is there. And we are not displaying any of the outputs. And that's just because we haven't turned the display of the outputs on. But okay, the results are there. You saw the analysis run. And what we're going to do now is, once we've created the BIM link, so that's with Checkbot, when you install IDEA StatiCa, you actually get an additional item here under add-ins within Robot. You see you've got IDEA StatiCa, and then IDEA StatiCa again, and Beam, and we'll just be clicking on IDEA StatiCa. This will open up the Checkbot and actually create the space where we can import this model and its loads into. So let's click on IDEA StatiCa, and unfortunately it's opening up on the other screen. So if you can just bear with me as we wait for that to open up and then jump straight into actually making use of the Checkbot. So luckily it's quite simple. So here we've got Checkbot, and the project name will be IDEA StatiCa and whatever this model is called, and the project folder will be the folder within which the robot model is situated in. So you have two project types, steel and concrete, and then we've got quite a few design codes, but we will be sticking with the Euro codes because they are the most relevant within the South African space. Then we click create project, and we will have a blank screen because we haven't imported anything yet. But so what we do is we actually click on other connections. So remember, depending on which one you are looking to design, in this case, we'll be looking at connections. And so what you do is you, in the robot space, you drag and select your entire model, go to Checkbot and click on this connections import button, and it will actually import all of the relevant data. All right, just a quick one. Before I do that, I want to show you something. Is if you look at how your members are orientated, so I'm talking specifically about how they're rotated about their longitudinal axis. That is very important because it is going to be detail that is actually taken up into Checkbot, and it will be a detail that actually forms part of your connection when you go proceed to connection design, and it's not something that you can change within the IDEA StatiCa space if using the Checkbot workflow. Okay, I'm not talking about actually creating a connection from scratch, just using steel connection directly. I'm talking about if you actually make use of the Checkbot functionality. Okay, so the rotation of your member about its longitudinal axis is very important that you get it right within Robot before you proceed to importing it into the Checkbot space. All right, so again, I'm just going to select my entire model. I don't have to display any loads, which is great, and I'll chat a bit about that just now. And then in the Checkbot space, I'm going to click on connections, and it's actually going to start the import process. So I'll actually just progress to the next step so that we don't have to sit and wait for about a minute or so, just because there's a lot of data to import. Alrighty, so once the import is done, this is what you'll see. And what happens is Checkbot actually picks up essentially all of the member intersections. It excludes the intersection point of these braces, and I'm honestly not sure whether that's deliberate. I think it should be, because wherever else members cross each other, or wherever else there's a member intersection, it actually picks up that it is a connection point, and you can see that by these little three-dimensional boxes. Okay, if you are unhappy with, or not unhappy, but if there is a connection point that you actually want to exclude just because you're not going to model it as a connection, and it won't be seen as a connection actually, you can select it by pressing escape first, just so that you can see that. You can select it and actually delete that particular point. So I'm going to delete a few of these just because I want to declutter the model a little bit. All right, so in the label section, I'm going to turn on connections, turn off members, and then you can select these and you can press delete and then proceed with that. Okay, and you can actually see that they're gone, and you can do that if you want to. You really don't have to if you don't feel like your model is cluttered and you're not struggling to see the connections that you want to see, then you really don't have to worry about going through this process. Okay, so what's really cool is, again, we can see that all of these intersections have been picked up, and that is why you can actually see here the orientation of the members have been kept as they were within Robot, and you can't change them, right? Even when I select them, you can see here there's rotation. I can't change any of that. Okay, so I want to design or start the modeling process of, I want to do N8 just because it's a very complex connection. You've got your column, 3 beams coming in there, and also your braces. And then I want to do something like N10 potentially, or N12. So it'll be interesting because we've got a really short, well, we don't have a lot of space there. And in practice, that might actually cause a little bit of an issue. But we'll see. We'll see how this all works out, and we'll figure that out when we get to actually modeling or creating those connections and, yeah, designing them. Right, something interesting to note is, or something really cool actually, is that prior to one of the latest updates, at least in my mind, it was quite difficult to pull in your load effects when you came from Robot. And you actually had to turn the display on and then select the model and then actually import them within the Checkbot space. And that seems like it is no longer a problem. So what I'm going to do, I'm going to select connection in8. You can see it identifies in8, and you can rename this. So let's rename this, actually, let's rename that. We're going to rename this part O2 connection. And then I also want, let's do in10 and call in10 part O3 connection. Okay. All right, so we can rename them. I'm going to select part O2, and you can see here just something to note, and I'll chat a bit more about this just now. But this result class as evaluation of critical effects activated, only critical effects will be transferred to the connection. Right, so I'm opening up this connection. What it's doing is it's exporting all of this geometry and the load effects into the IDEA StatiCa connection module, which is where all of the cool stuff happens. All right, so we've got that over here. You can see all of the geometry there. You can actually see the members rotated. If I select them again, you can't adjust this. That's why it's important to get this right within Robot. And we have got a ton of load effects. So again, when I run the analysis, I'll actually just skip over that that duration, so you don't have to sit and look at the screen for about maybe 10 to 20 minutes. We don't know how long that analysis is going to take. But right, so something important here is if we click on one of these load effects, you'll see that there's a very cool description for us, which is brilliant. And then it consists of axial forces, shear forces, and moment forces. Okay, now that should tell you something. So the load effects are not the same as your imposed loads. Okay, and that's something that I struggled to wrap my head around initially, because it isn't normal to have to work that way, or rather, okay, not normal doesn't sound great, right? But it isn't actually common practice that a program works with load effects versus your imposed loads and then calculates those load effects for you. But so with Checkbot, what's really, really cool is that the program actually pulls in the load effects for you. All right, so basically, if you think in Robot, you're displaying, after you've run your analysis, you're displaying the bending moments, the shear force, etc. Those are the values that are imported here, and they're relevant to these load effects, which is absolutely brilliant. And these will come down to all of the load combinations, etc. And an important thing within the IDEA StatiCa space as well is that loads are in equilibrium. And you can actually see here, because these load effects are based on the load effects relevant to a specific node, which is what a connection is, a nodal point with members coming into it. They would always, even if you had to do the analysis by hand and check the results, those forces would have to balance out around that node. Okay, and as you can see here, if we look at all of these load effects, that the forces are balanced out, and that is phenomenal. Okay, if you had to add this sort of data manually, if you've got a very simple connection, it's all good and well. But imagine having to go through checking all of these load effects around this particular node within Robot. So even something like Sumo that would make that a lot simpler, it would still be a very difficult process actually, because you need to get your signs correct, and they don't necessarily speak to each other in terms of the sign convention and so forth. So that's something that you'd have to figure out there. But with Checkbot, that information is pulled through for you. Now, just a quick one. What's very cool is that the same functionality is going to become available, or the same integration is going to become available for all Sumo users sometime soon. We don't know when, but we know that it's in pipeline, which is really very, very cool. All right, so we've got our connection in here, and we're quite happy. We're quite happy with the way things have been set up. And you can actually, what you can still end up doing is actually changing the model type. And this is relevant, or this has to do with actually what is the boundary conditions or the fixities of this memory. Would it have normally been pinned? Would it have been torsionally pinned, etc.? And you can still end up changing that. So what is the effect of that? So if I change this to NVYVZ, does it have any sort of an effect? And the answer is, to a large extent, yes, because what it does is it actually, what I believe it does, is it nullifies those values over there. So it makes the effect 0, I think. So I'll need to clarify that and actually find out what happens when I change that, the model type of a particular element, and yet because I potentially didn't set it up correctly within Robot, those values pull through. Should I now actually go back to Robot? Should I change the fixities or the end conditions, or can I actually just change the model type here and the effect will be the same? I don't think that it could, because you think of how your forces are transferred through a model. If you change the end conditions of a particular element, it will change that, so it will have an effect. So I'll do a bit more digging about what we can expect from changing the model type, and then that will be something we can discuss in a future video. But with this connection here, with the part 2 connection here, I'm going to end this particular clip. This is the end of part 1 so long, and then we are going to jump into our part 2 of this series, and we're going to start building up this connection, which is going to be really very, very exciting. So thank you so much for tuning in. If you have any questions, if there's anything that you're concerned about, anything that just tickled you a little bit, please pop something in the comments, or you're always welcome to mail me directly. So thank you so much for tuning in, and hope you have a lekker afternoon further, or lekker day, and I'll check you in part 2.